And let's give it a shot, see what happens. There we go, and it's turned on. This project is for turning on a computer using a optical fingerprint sensor. Here's a quick schematic of what it looks like. We'll start right here with the RGB LED. This is just an RGB LED to show the state of the fingerprint sensor so we know if it's ready to accept a fingerprint, which will be shown later. I have over here this ultrasonic sensor here is actually the optical fingerprint sensor. Tinkercad didn't have an optical fingerprint sensor available, so I just used this one because it has 4 pins. So pin 1 is just voltage in, pin 2 is the ground pin, and then we have 2 pins in here for serial receiving and serial transmitting. And those ones just go into 2 pins on the Arduino. And then over here, the power supply over here, this is to represent the headers on a motherboard on a computer that would normally connect to your power button. So we have the positive voltage side of the power button headers here going into a transistor, which just bridges over to the grounded side of that. And it's also grounded down to the Arduino here. And that's just controlled via a output pin here, a digital output that turns the transistor on or off. And this basically acts as the power button on your computer. I have a schematic here, an actual circuit diagram. This is the exact same thing. It's just the more technical one instead of the 3D rendering or the 2D rendering. And over here we have the headers from the computer, in case you guys are wondering what this power input is. And over here we have the sensor. I need to rename it. It says distance 1 right now, but it should be fingerprint sensor. And then the RGB LED over here. Here's a quick look at the code. So we use the example sketch from Adafruit's fingerprint sensor. They have 2 sketches. One is to enroll fingerprints, and one is to activate a lock or unlock a lock. So I'll go through it really quickly. Basically, we just set up some pins here for the RGB LED. We set up a pin here for the lock. I made one named PC pin because I've used this as a lock, but also for the PC power button. Finger status just refers to whether a valid print has been entered or not, or if it's waiting for one. And then we have a locked state, or in this case, a state telling you whether the PC is on or not. And then an RGB helper function just to set the colors of the LED. And this one came with the example sketch. Basically, it just locks for 5,000 milliseconds. It locks for 5 seconds, that means, and then it unlocks itself. Or the other way around, it unlocks for that long, and then it locks itself. Here's 2 that I coded up. There's one for unlocking a PC and locking a PC, or powering on and powering off. Essentially, it just sends the digital signal on pin 13 for 200 milliseconds to simulate pressing in your power button. And then the one that turns the PC off, it does the same thing, but it does it for 10 seconds. Usually 5 or 7 seconds is sufficient, but it depends on your device. I just have it defaulted to 10 because holding the button longer usually doesn't do anything different. Okay, so basically, it starts up a serial monitor just so that you can visualize your results. And then it starts checking for fingerprints here. If it finds the fingerprint sensor, if the wiring is all hooked up properly, it'll let you know. If not, it'll warn you. And then here it gets templates based on fingerprints that you've enrolled already, and then it waits for a valid fingerprint. This code here is just, again, to set up RGB LED outputs, and then we set the PC on state to false by default. Okay, here's our loop. it starts at a delay for 50. This is just to slow down how many inputs it's receiving. This was just for testing. It sets the RGB LED to a yellow color. That way we know it's ready to go. And then it does a check to check for IDs. We have multiple IDs that it can check. I have index finger, pinky finger, and thumb all registered. So there are multiple ones it can check. But if any of those are valid, if the PC is currently on, it'll turn it off. If not, it'll turn it on. If it's invalid, it'll set the RGB color to red, and then it'll wait for 2 seconds so that you can't keep putting inputs. This delay could be longer. You could put a counter there to lock people out after a certain amount of time, but for now it's just doesn't accept it. Down here under the matches, for thumb it sets the color to green, sets the index to blue, and the pinky to purple. This is just so you can visualize different fingers. That's the code for the fingerprint lock. Let's open up the code for enrolling real quick to take a look at it. Okay, here's the code for enrolling the fingerprint. Again, this is an example sketch from Adafruit. It sets up a serial monitor here. And when it begins, it lets you know that it's starting to enroll. Again, it'll warn you if the fingerprint sensor is connected or not. And then here we go, it starts reading. In the loop, it just says ready to enroll. And then you type an ID in that you want to save it as. So for example, on the other sketch here, I have my, where are they? Down here, finger ID 1 is my thumb, finger ID 2 is my index, and finger ID 3 is my pinky. That's essentially what you're doing here in the ID one. You just can't use number 0. It starts indexing from 1, so it warns you about that. And it can roll up to 127 different fingerprints. So you could have 127 different people with their thumbprint, or just 127 different fingers. Once you're done that, then it waits for you to put your fingerprint on it. And then once it detects that there's a fingerprint, it'll let you know. It'll say image taken. If it doesn't find a finger, it'll just tell you that. And there's a few other errors here for different cases. On success, it'll let you know if it was converted. If it's too messy, again, bunch of error checking. It'll tell you to remove it. And then it'll tell you to do it one more time. That's to make sure it got the read properly. So it does 2 reads. It makes it a little more accurate. And then again, just a bunch of error checking, and creates the model, and you're good to go. So that's all of the code side. The important stuff is just going to be right here. That's the code that actually operates, turning the PC on and off. And the setup up top that we did earlier. I'll show you that as well, this stuff. I have a breadboarded circuit for the fingerprinter sensor here to show how it could be used to turn on and off a computer or any other electronic device for that matter that is operated with a switch or a power button. So it's pretty simple. It's just the fingerprint sensor here. I have an RGB LED that I've programmed to show just different states of when it's ready to accept a fingerprint, when a valid fingerprint has been entered, and when an unrecognized fingerprint has been entered. And then over here, the circuit for the computer's power switch is quite simple actually. Sorry for the power button. It's just a digital output pin coming from the Arduino here that controls let's get into focus. That controls a transistor over here. And that transistor just collects 3-volt power input, and it sends it over here to an LED with a resistor in between. In the actual PC case, what this would do, on the collector side, it would be connected to the 3-volt header for your power button, and the emitter side would be connected to the ground header for your power button. So I'll show you guys how it works. I'll start by putting in an invalid fingerprint here, and we should see the LED turn red. So I haven't submitted my index finger. I haven't registered my index finger. So when I put that there, we'll see the LED turns red. It's not a valid fingerprint, and if I zoom out a little bit, we will see that the LED does not light up. Sorry about the light leakage here, guys. But if I use my thumb, what we should see is the LED on the left will flash blue for 200 milliseconds. And that simulates just turning the PC on, quickly pressing the power button. Now that it's on, if I hold my thumb again, we should see the LED on the left turn blue for a full 10 seconds. And that's just gonna simulate holding down the power button on your PC to do a forced shutdown. Now you could leave it so it only flashes for 1 second. So let's do it again, or the 200 milliseconds I have it programmed for. Just like this. Oh, it's not registering my thumb. Let's give it a reposition here. There we go. And you could just leave it on the 200 millisecond one because that shuts down most PCs. I've programmed in a 10-second version just to simulate a forced shutdown, just in case your computer freezes or anything like that. And you could just have a button that switches between those two modes. I just have them switching automatically every time one is entered. But yeah, that's the entire circuit. It's currently powered by a 9-volt battery, but if you wanted to put it inside of your PC case, what you could do is you could just hook up the voltage in pin that's right down here. You could just have that going into a 3-volt output on your motherboard. Plenty of motherboards have these, so you could power it just inside the case. And then yeah, just remember all it is this little transistor here. The base is going to be connected to the output pin on the Arduino. The collector goes to the 3-volt output header for your power button, and the emitter goes to the ground header for your power button. But yeah, that's the whole thing. It's pretty simple. Most of it's just done in code. Okay, so I've got the 2 jumper cables down here plugged into the headers for the power button on the PC. So normally that just connects to right up here. But essentially what I've done is hot wiring the PC. So now when I cross these 2 wires here, you'll see the PC turns on. Okay, so now that the computer is running, if I hold these 2 together, for me it's about 7 seconds, we should see this power down. There we go. So basically these wires are just going to connect into the circuit along the transistor. Okay, so I have everything hooked up here. I've got 2 jumper wires coming out of the pins on my motherboard for the power button. So normally they just connect right up here to the power button, but it's currently disabled because I have them jumped over here instead. So they're just going to either side of this NPN transistor here. And the green wire here goes to the ground side, which I also have grounded off onto the Arduino. The orange side is the 3-volt power source that comes into the button normally. And the yellow wire here is just going to a digital pin on the Arduino. It's currently on digital pin 13. And that is what is triggering the transistor. So when I hold down my thumb on the fingerprint sensor, you should see 2 things happen. The first one is going to be that this LED over here turns green, showing that it has accepted the fingerprint. And then we should also see the computer turn on. So let's try to get both of these in view here. It's a little hard to see, but I think that's the best we can do from this angle. And let's give it a shot, see what happens. There we go, and it's turned on. Then we can see up here, if we give it a minute, the monitors turn on. And let's just make sure it posts and it's all booting up properly. All right, there we go. We've gone into my dual boot menu here. And there's my desktop, or my login screen, I should say. And so now, if we go back to the fingerprint sensor here, if I hold down on it, it'll send a signal for 10 seconds. And we should see here in just a moment, the PC shuts off. There we go. So that's it. That's how you control your PC's power using a fingerprint sensor. If we want to make it more elegant, we just have these jumper cables going directly to the transistor. We don't need the breadboard or anything. And then we can have the voltage in on the Arduino powered by one of the motherboard pins. But let's just show it one last time here. All right, there it is.